Okay, so we've now seen the three ways that we use the concept of equality, and now we're going to apply this to a slightly more challenging problem, which is to draw the tangents or the tangents to our ellipse at the point where x equals 1, and in this is going to illustrate all three concepts. So we're going to draw the first tangent line, which is the tangent at the lower point on the ellipse where the variable x is equal to 1. So let's establish those coordinates by taking our coordinates, applying the first solution for them, setting x equals 1, and then applying the parameters appropriate to the current ellipse. So we do that, and this tells us that this point is the point 1 and minus the square root of 3 over 2. We'll keep that for future reference. So to find the normal vector, this is the vector which is perpendicular to the tangent at the point, then we take the partial derivatives of the equation for the ellipse and differentiate those with respect to the coordinates. So we make a table of these which is has the length of the number of coordinates, and then we evaluate that at the current solution at the point, at the first solution at the point where x is 1, and for the current values of the parameters. So this gives me the components of the normal vector, and that's it there. And now to calculate the equation of the tangent, we know that the line connecting the coordinates of a point on it to this value or the point we're looking at, if we take the scalar product of that with the normal vector, then that should be 0. So let's do that, and this gives me an expression here, which is the left-hand side of an equation, which can be set equal to 0 and solved for y as a function of x using this. Jumped up a bit on us. So we set the tangent equation logically equal to 0, use the solve function, and try and find the value of y, and I've used this construction Mathematica function flatten, which just removes excessive numbers or pairs of these kinds of brackets. And now we want to draw this line, so we choose the values of x at its endpoints. So we'll take that as those to be 0 and 2. We could change them, we'll see what the result is. And then we want to draw a graph of this line for the current values of the parameters and all that kind of stuff. So we execute this statement here, and that gives us a line. And now we can superimpose that line on the ellipse using this. So this show function combines two graphs, and so we do that, and there we see that it's drawn the tangent to the ellipse at this point. Not a non-trivial and rather typical problem which first-year students are asked to solve. Well, now I'm not going to do it, but we could easily make a copy of this here and customize it to easily draw the tangent on the upper part where x equals 1. Anyway, that's the end of this story, so I hope that you enjoyed it.